So this is the Sock Shop demo running on Power and Intel. This is also running on the OpenShift container platform. So this is a canonical absolute best example of using a microservices across Intel and Power. And so you'll find this used in a number of different spots. You can see in this application, it's about selling socks. It's just simplistic, right? Well, this simplistic application, I can go ahead and order a pair of socks. So I've added it to my cart. If I go visit my cart, I can see that that's a pair of socks are there. Well, it's backed by a microservices application. The microservices application has a Go application in it, custom developed for this purpose. It has a Java application. It has a Node.js application. Actually, this front end is all in Node.js. And so what IBM did is we ported over this canonical application called Sock Shop over to 4 architectures: AMD 64, ARM, PowerPC 64LE, S390X. That allowed us to demonstrate the power of using a multi-architecture compute cluster. All of our images are first manifest listed, but also provided in single architectures so that you can experiment with different use cases. So we have deployed this in a cluster, and it is running across different architectures. So you're going to see right in the center here in this node column, worker 1, worker A-0. This is my way of indicating a different architecture, and worker 1, and it's spread across worker 1 and worker A0. So if I choose to, I can fail my workload for, say, let's just pick the front end because it's the easiest application to move and quickest. We can delete the front. Oh, first we actually need to look at the nodes. OC get nodes, O wide. And the key for seeing where each of those pods is laid out, we print the wide, then we see worker-1. Then we look here, worker-1, and if we look on this line with worker-1, we're going to see a uname with a PPC64LE. If we look at worker A0, and we can see down here on this line, the uname is with x86_64. So 2 different architectures entirely. So if we then go ahead and cordon our Intel node, we can actually fail our workload for our front end over, and you won't actually see any disruption in the application. So delete pod. We need to wait for it to come live, so we're going to do OC get pods. We're going to watch it, and we're going to find the front end. It's been up for 15 seconds. It's no longer on the Intel node. It's now on worker 1. We're going to switch back over here, and let's just go to the home page. You can see a slight pause as it's rebuilding the cache, but it hit the back end. It made some real requests. So now you've just seen us fail over, still maintaining the session and state, still have it in my cart, an application using microservices spanning across 2 architectures successfully on an Intel and Power cluster. It's pretty powerful. Thank you.